myself Senthil Kumar. Today we are going to see basic core types in current transformer. We have 0.2 class, 5P10 class and PS class. We will see accuracy and um, uh, how PS class we can see accuracy and um, other things. Okay, so first we will move to first 0.2 class is a metering class CTs. We have 0.5 class also. A 0.2 class means 0.2 percentage of a composite error at rated burden. Very simple, used in meters, especially for the energy billing. The second one is the 5P10. 5P10, 5P20, anything. We see one example 5P10. 5P means 5% maximum composite error at 10 times of the rated current. So this here 10 means accuracy limit factor. So 5 composite error, 5 percentage maximum, and this accuracy limit factor. So in common, how we can tell the error must not exceed 5% at 10 times of the rated current. That is called 5P10. So the next one is PS class. This is a special protection special class. Here you can see high accuracy protection, mainly used in differential and distance protection. Here in earlier case we know what is the maximum error. Here we don't know the what is the maximum error as said by 5P10 or 0.2 class. So how we calculate means we calculate based on the VK knee point voltage. We already know what is knee point voltage. Every 50% rise in magnetizing current, 10% voltage increase. So if you keep increase 10%, the current also increase 10%, but at certain point the current suddenly rises more than 50%. That point is knee point voltage. Exciting current at VK is very important, and we have to calculate secondary burden voltage. How we have to calculate secondary burden voltage, that we will see here. So VS, normally we call it as VS. We move to the next slide. So there I have given the details. So how to calculate? We need first burden of CT burden, lead burden, all secondary burden we need. So if you say that is ZB, then we should take the fault current, maximum fault current. So in multiplication of fault current and the burden will give you VS. So now how to select VK of the particular core? VK should be 2 times the VS. Okay. And what is the magnetizing current? As per IEC 60044-1 or IS class 2705, we can use it. But according to me, it should be less than 100 milliampere at VK. So normally if you see all this course nameplate, it is mentioned a magnetizing current at VK, or sometimes magnetizing current at VK by 2 kind of values given in the nameplate. So based on this value, you can compare this, you can calculate VS and VK, then you can decide whether the CT is within the accuracy limit or not. So in this way only we can go for accuracy limit. One example we can go for one example. So accuracy check for a PS class. So for example, 1000/1 ratio, and burden is 2 ohm, and fault current is 20,000. That means 20 times. So at normal condition, VS is 1 ampere normal current, 2 ohms burden. So the resulted is 2 volt. At fault times, because earlier we see in the fault we have to multiply fault current with burden, so we get 40 volt is VS. So what is the VK required is 2 times, so 80 volt is the VK. So and that VK, the magnetizing current should be less than 100 milliampere. If all satisfied, then the CT is within the suitable limit. Okay, so this is how we have to check the accuracy class for PS class cities. Okay, so then what is another one? ALF. What is ALF? How to calculate ALF for this PS class cities? So here also so you can see here ALF means VK divided by fault current into burden. So in this formula you can apply and you can calculate the accuracy limit factor for PS class. For example, 100 volt burden is 2 means then fault current. So if I here it is given 1 ampere, but you have to use fault current. So here if you multiply 100 divided by 20, that 5 times. Okay, so this is how we have to calculate the accuracy limit factor for PS class. Okay, thank you.